Hello students, let us solve some problems from the topic circle of standard 10th maths part 2. So we'll solve some examples from practice set 3.1. The first question is, in the adjoining figure, radius of a circle with center C is 6 centimeter. Line AB is a tangent at point A. From that, answer the following questions. So here it is, the circle is given with center C. Radius of this circle is given to be 6 centimeter. Line AB is a tangent. And from this, we have to find the measure of angle CAB, that is measure of angle CAB. So we have to construct segment CA. Second question is, what is the distance of point C from line AB? We have to find the distance of point C from line AB. If distance AB is 6 centimeter, find distance BC. If AB is given to be 6, from that we have to find BC. And the fourth question is, what is the measure of angle ABC? To solve this question, we need to do some construction. That is, we have to draw segment CA, which is the radius of the circle. And we have to join point C and point B. That is, we have to draw segment BC. Now, as CA is the radius and line AB is a tangent, this radius must be perpendicular to a tangent by tangent theorem. So here we can write segment CA is perpendicular to line AB because tangent is perpendicular to the radius. And that's why measure of angle CAB is equal to 90 degree. So this is the answer of the first question. Now to find the answer of the second question, we have the radius of a circle is 6 centimeter, that's given. And CA is perpendicular to line AB. That means CA is the distance of point C from line AB. And as CA is a radius, it is 6 centimeter. That's why the distance of point C from line AB is 6 centimeter. This CA is 6 centimeter. Now to find the answer of the third question, we have angle CAB is 90 degree. That's why triangle CAB is a right angle triangle. And in that we can write by Pythagoras theorem, that is hypotenuse square is equal to side 1 square plus side 2 square. So in this right angle triangle, hypotenuse is BC. That's why we have written here BC square or CB square is equal to, remaining two sides are AB and AC. That's why CB square is equal to AB square plus AC square. And this is written by a Pythagoras theorem. Out of which we have the values for AB and AC. So the length of AB, it is given to be 6, and length of AC, that is the radius of a circle, which is given to be 6. So we'll replace here AB and AC by 6. So we should have 6 square plus 6 square, that is 36 plus 36. So CB square is equal to 72. Now we have to find CB. That's why we have to take square root on both the sides. So CB square root of CB square is CB is equal to under root 72. Now we can split 72 as 36 into 2. That's why as 36 is a perfect square, if we take outside the square root sign, its square root should be taken, that is 6 into root 2. So the length of CB is 6 root 2. Now to find the answer of the fourth question, we should consider triangle ABC. So in this triangle ABC, it is given that AB is 6, AC is also 6. That's why these two sides are congruent. That's given. If in a triangle two sides are congruent, the opposite angles are also congruent. That is by isosceles triangle theorem. That's why angle ABC is congruent with angle ACB. Now let measure of these two angles, that is angle ABC is equal to angle ACB is equal to x degree. And now consider sum of measures of all the angles of this triangle, that is angle ABC plus angle ACB plus angle CAB is equal to 180 degree, because sum of measures of all angles of a triangle is 180 degree. I will replace the values of angle ABC and ACB, that is x degree, plus angle CAB, which we have proved to be 90 degree. So we'll replace here angle CAB by 90 degree is equal to 180. X plus x will have 2x plus 90 is equal to 180. We'll transfer 90 to the right hand side to get 2x is equal to 180 minus 90 degree. That is 2x is equal to 90. To find value of x, we'll transfer 2 to the right hand side. So that will be in the denominator. 90 by 2, that's 45. So angle ABC, which we have assumed to be x degree, is 45. So this is the answer of the fourth question. Let us consider the second question. Here one diagram is given, and based on that we have question. O is the center of the circle which is given. From point R, segment RM and segment RN are the tangent segments which touches the circle at point M and N respectively. If length of OR is 10 centimeter, so the length of OR is given to be 10 centimeter and the radius of the circle is 5, then we have to find what is the length of each tangent segment. So here tangent segments are RM and RN. We have to find their lengths. Second question is, what is the measure of angle MRO? This MRO, we need the measure of angle MRO. And the third question is, what is the measure of angle MRN? So let's try to find these answers. For that again, we have to do one construction. We have to draw a segment OM and segment ON. So the figure will be like this. Now in this, we have OM is equal to ON is equal to 5 centimeter because OM and ON are the radii of the circle and it is given to be 5 centimeter. OR is given to be 10 centimeter. Now here we can have OM is perpendicular to MR because OM is a radius and MR is a tangent. And we know that tangent is perpendicular to radius by tangent theorem. That's why OM is perpendicular to MR. Now in triangle OMR, as this angle is 90 degree, triangle OMR is a right angle triangle, and in that we can use the Pythagoras theorem. So by Pythagoras theorem, we have hypotenuse square is equal to side 1 square plus side 2 square. So in this triangle, hypotenuse is OR. So OR square is equal to OM square, that is the first square, plus MR square. So we have written here OR square is equal to OM square plus MR square by Pythagoras theorem. Now we have the length of OR and OR square is there. So 10 square is equal to OM, which is also given, that's radius 5 centimeter, 5 square plus MR square. Now if we simplify this, 10 square is 100, 5 square is 25 plus MR square. We transfer 25 to the left hand side to get 100 minus 25 is equal to MR square. 100 minus 25, that's 75 is equal to MR square. If we take square root on both the sides, we will get root 75 is equal to MR. Again, 75 can be split into 25 into 3. So as 25 is a perfect square, if we take that outside the square root sign, it will be its square root. So 5 root 3 is equal to MR, that is MR is equal to 5 root 3. Now as we know that if there are two tangent segments drawn from an external point, those are congruent. So if MR is 5 root 3, the another tangent segment that is drawn from same external point R, it is Rn, must be also 5 root 3 centimeter. That is length of two tangent segments drawn from point R. That is MR is equal to NR is equal to 5 root 3 centimeter. Now to find the answer of the second question, in triangle OMR, again angle OMR is 90 degree. So if OM, that is the radius, and OR, that is the length of segment OR, is given, we have OM is 5 and OR is 10. And as we know that 5 is half of 10, that is OM is equal to 1/2 of OR. So in this triangle, as measure of angle OMR is 90 degree, this triangle must be 30 degree, 60 degree, 90 degree triangle because the length of side OM is half of the hypotenuse. Hence, angle opposite to side OM must be of measure 30 degree. So, measure of angle MRO is 30 degree. Similarly, we can prove in the triangle ONR, the measure of angle NRO, that is also 30 degree. And measure of angle MRN is the sum of two smaller angles, that is angle MRO and angle NRO. If we add these two angles, we get angle MRN. So angle MRN is equal to angle MRO plus angle NRO, that is 30 degree each, 30 degree plus 30 degree, so that is 60 degree. So that is the answer of the third question. Now let us consider the next problem. Again, the diagram is given, and in that segment RM and segment RN are tangent segments of a circle with center O. So RM and RN are two tangent segments given, and we have to prove that segment OR bisects angle MRN as well as angle MON. So we have to prove OR is the angle bisector of angle MRN and angle MON. So let's try to solve this. So diagram is given over here. As OM is a radius, RM is a tangent, OM is perpendicular to segment MR. Similarly, ON is the radius, NR is the tangent. ON must be perpendicular to segment NR because tangent is perpendicular to the radius. Hence, measure of angle MOMR and ONR is 90 degree each. Now consider these two triangles, triangle OMR and triangle ONR. In these two triangles, segment OR is congruent to segment RO because this is a common side for both of these two triangles. We have another constituent, that is segment OM is congruent to segment ON because these are radii of same circle. So in these two triangles, hypotenuse and one side is congruent. That's why these two triangles must be congruent by hypotenuse side test. That is, triangle OMR is congruent to triangle ONR by hypotenuse side test. And we know that if two triangles are congruent, their corresponding angles are congruent. That's why if we take angle MRO, its corresponding angle is NRO. So angle MRO is congruent to angle NRO, and angle MOR is congruent to angle NOR, and this is because corresponding angles of congruent triangles. And that's why, as these two angles are congruent, MRO is congruent to NRO and MOR is congruent to NOR, segment OR must be bisector of these two angles. That is, segment OR bisects angle MRN and angle MON. The next question is, what is the distance between two parallel tangents of a circle having radius 4.5 centimeter? So there is one circle given with radius 4.5 centimeter, and we have to find the distance between two parallel tangents. So for this we have to draw a diagram. So let us have a circle with center O, and there are two tangents AB and CD which touches the circle at point M and at point N respectively. And it is given that these two tangents are parallel. Now to find the distance between these two, we have to find the length of MN. But for that, we have to prove that M, O and N are collinear points. Now to start with, let the tangents AB and CD touches the circle with center O at points M and N, which is given. Now we have to draw segment OM and segment ON to find the length of MN. And we have to do again one construction, that is draw line XY which is parallel to line AB. And line XY passes through the center of the circle, that is O. Now if we do this construction, we have got two angles, that is angle AMO and angle MOX. So these two angles are interior angles, and we know that if two lines are parallel, interior angles are supplementary. That's why angle AMO plus angle MOX is equal to 180 degree. Now out of which angle AMO is 90 degree because AB is a tangent and OM is the radius. And we know that tangent is perpendicular to the radius by tangent theorem. That's why measure of angle AMO is 90 degree. So we'll replace here angle AMO by 90 degree plus angle MOX is equal to 180. If we transfer 90 to the right hand side, we'll get measure of angle MOX is equal to 180 minus 90, that's 90 degree. So here, as we can see in the diagram, measure of angle MOX is 90 degree. In the same way, we can prove measure of angle NOX is equal to 90 degree. And now if we add these two angles, it is angle MOX plus angle NOX, we get 90 degree plus 90 degree, that is equal to 180 degree. And as we know, for angle MOX and NOX, we can see OM and ON are the opposite rays, and these two are adjacent angles and supplementary. That's why angle MOX and angle NOX are angles in linear pair. And if these two angles are angles in linear pair, points M, O, and N are collinear. And if these 3 points are collinear, then we can write MN is equal to MO plus ON. And OM and ON are the radii of the given circle. And radius of this given circle is given to be 4.5 centimeter. That's why we will replace here OM and ON by 4.5. So we get 4.5 plus 4.5, that is equal to 9 centimeter. So this is the length of MN, which is the distance between these two tangents. So distance between these two parallel tangents is 9 centimeter.